Hi everyone, welcome to our video on computing limits algebraically. So to compute a limit algebraically would means we use algebra to answer it, which really means like we really wouldn't use a calculator or graphing, but I mean obviously those would be helpful for some of these problems, so if we can, might as well use those too. Okay, but for this scenario, I am going to do them all by hand first, and then we could use our graphing tools to help us after. Okay, so to compute limits algebraically, the process for this, to find some limit, first, just evaluate the whole thing. If it is defined, so that means like if we get a number, so like in these last two, we got a number, that means we're done. We have the answer. However, a lot of the times we'll get something divided by 0, which means it's undefined. So remember, undefined is if we divide by 0. Then we have to try something else, which involves these three. So it just depends on the scenario. So we either try factoring. If we have radicals, we'll try multiplying by the conjugate. If we have complex fractions, so that means if you have fractions and fractions, so complex fractions, we'll multiply out the common denominator. Okay, so those are the three cases that we see most often. And then we also have some little rules that can kind of help us, where we could like factor out the negative, or we also want to still consider left-hand side and right-hand side if it's a more complicated function. Okay, so anyway, so let's see how we could do these problems. So in this one, we have the limit as x goes to 3 of a rational expression. Okay, so first thing I really want to do is just plug 3 in to check. So if I plug 3 in, I'd get 3 squared plus 4 times 3 minus 21 over 3 squared plus 2 times 3 minus 15. So this is me plugging the 3 in to see if it would work. So just kind of a scratch area. And well, if I plug it in, I'd have 9 plus 12 minus 21. Well, that does simplify to be 0. Down below, I have 3 squared is 9 plus 6 would be 15 minus 15 is also 0. Okay, so dividing by 0 is an issue. By 0 issue. Okay, and it doesn't really matter that that's 0 up there. It's the 0 down below is the issue. All right, so what that means is, because each of these is a polynomial, what we'll do is factor. So this is our factor case. So, and that's kind of true again if you have quadratics in any form. Often it's worth a while to factor. So if we factor it, so notice I'm going to continue writing the limit. So we always write it until we actually plug in 3. All right, so we're going to factor this. Now, to factor this, I'm going to use our scenario to the right here, just kind of scratch paper. I know 1 times negative 21, just as a quick refresher for this one, is negative 21. The factors of 21 are 1 and 21, and 3 and 7. And I know a positive 3, or a negative 3, and a positive 7 is what would give us that positive 4. And then notice that these multiply and give us negative 21. Because the coefficient is 1, I'm going to factor it as x minus 3 and x plus 7. Okay, for this factoring, let's go ahead and skip the scratch work. If you need it, use it. But to save a little time, I'm going to go ahead and factor it by looking at our negative 15. It looks like I know I would have 5 and 3 to give us a positive 2. So I think it's going to be x plus 5, x minus 3. And remember to quickly FOIL and check. It will match what is down below. Okay, and then now that it's factored, well, we'll use our rule where if you have a factor that is the same in the numerator as a denominator, then these just cancel out. So what this becomes is the limit as x goes to 3 of just the x plus 7 over x plus 5. And then now that they're all canceled, or now that we've canceled something, now what we want to do is try to see what happens when we plug 3 in for those x's. So if we plug 3 into the x, that means I no longer will be doing, I no longer need this limit notation. It's saying I am plugging the 3 in. I'd have 3 plus 7 over 3 plus 5. And then, well, we would just simplify. So 3 plus 7 is 10. 3 plus 5 is 8. And then, well, reduce it. It becomes 5/4. And that's it. And there we go. Okay, so that's how we can solve these problems purely by hand. All right, so on number 2, let's do this one by hand as well, and then we'll also check it with a calculator. All right, so on this number 2, we have the limit as x goes to 4 of this expression. Well, again, just a quick check. If I plug 4 in, well, 4 squared is 16, minus 4 times 4 is also 16, over 16 minus 4 squared is 16. And so we get 0 divided by 0. Okay, so again, that's an issue. The 0 down below means we need to work on this in a different way. Well, let's try factoring again. Since these are both polynomials, we can factor. Okay, so what we've got is still the limit as x goes to 4, fraction. X squared minus 4x has an x in common that we can take out. So it's x times x minus 4. And then this down below is the difference of squares. So I know 4 times 4 is 16. So I can set this up as 4 minus something and then 4 plus something. Because again, 4 times 4 is the 16. And then x times x would be the x squared. So it's 4 minus x and 4 plus x. Okay, and then looking at what I have in the numerator with what I have in the denominator, it certainly looks like these two are very close to being the same. However, they're not exactly the same. So remember when you cancel, like what I have highlighted in yellow in the previous problem? Those are exactly the same, and so that means they divide. These are not exactly the same. The order's not correct. I need to make sure that they are the same. Okay, and the quick way to do that is to factor a negative out of one of them. So I'm going to factor a negative out of this one. A negative 1. And so what that does for us, let's put it over here. So I've got the limit as x goes to 4. So the top I'm not going to mess with. It's just, I'm keeping it the same. Now what I boxed in blue, I want to factor a negative 1 out of it. So I'd have negative 1. And then all that does is change the signs. So this positive 4 is now negative 4. This negative x is now positive x. And then I still have 4 plus x in my other parenthesis there. Okay, and the reason that we did that is because, well, in the blue, I can rearrange now. Okay, so subtraction, you have to be careful with rearranging. This is a plus with a negative number, so that means you could rearrange it. Okay, so you've got the limit as x goes to 4. Again, the top is fine. The bottom, I have negative 1. Now, I'm going to rearrange, so it's positive x, so that means I could put positive x first, minus 4 second, and then 4 plus x after that still. Okay, so I'm using the commutative rule, really. So remember, like 3 plus 5 is the same as 5 plus 3, so those are both 8. So the order didn't matter. And the order doesn't matter as long as we take the sign with it. So for instance, if we had negative 3 plus 5, this would be the same as 5 minus 3, okay, because I kept the signs. Okay, be careful though with minus, like 5 minus 3 would not be 3 minus 5. Okay, be careful, so you can't just switch those two, because this is positive 2, this would be negative 2. However, 5 minus 3 would be negative 3 plus 5. So again, keeping the signs, it is the same. So this is positive 2, this would be positive 2. Okay, so that's why I didn't want to just switch x and 4 to get a match and just cross it out immediately, because I wouldn't have had the same thing. Okay, so it would have been this scenario. That would have been wrong. So that's why I had to factor out the negative 1 first to be able to rearrange it into its match. Okay, so now they are matching. Okay, and then now I can cancel them out. So this x minus 4 and this x minus 4 cancel. So then it becomes, let's put it kind of over here. I have the limit as x goes to 4 of, okay, so canceling that out, I have x all alone up top. And then down below, I have negative 1 and 4 plus x multiplying it. And then now is where I want to just plug in 4 into my x. So now I'm going to apply that limit value, which means I no longer write the limit. I just write the expression. So 4 goes into that x. And then I have negative 1, 4 plus 4 down below. And then now it's just simplify. So I have 4 over, this would be 8. 4 plus 4 is 8. -1 multiplying it would be -8. And then this simplifies to be -1/2. Okay, so that's doing it purely by hand. Now, we can use the calculator to help us. Let's go ahead and look at it. Let me bring one up. So here it is. Okay, so I just typed in Desmos. That's the main one that I use. GeoGebra is also a decent one. Okay, so that it suggests that. That's a good one too. Okay, and I usually just do the graphing calculator. You could do scientific calculator as well. But anyway, graphing calculator is just fine. And then all I want to do, so I want to plug this function in as shown with the parentheses. So parenthesis x squared minus 4x divided by 16. Oh, let me get the parentheses. 16 minus x squared. And then parenthesis. And then that way we can see the function that's graphed. And what I want to do is look at it when I have x is 4. Okay, so when x is 4, so notice it says it's undefined. That's okay. But look at the values that are right next to it. So -0.49, -0.5. So it's looking like, okay, so both of those are looking like it's at -0.5. And you can kind of zoom in if needed. So I'm just using the middle roller on the mouse. And we can kind of see, well, that is, it looks like it's right in between. There's 0.5, right? -0.5, I mean. And it looks like, oh yeah, it's going through there. Okay, so visually we can kind of see it. You could also use the table function, convert to table, and then plug in. Notice 4 would give you an undefined. But if you plug something in very close to 4, like 3.999, we get something that's very close to -1/2. And also if we plug in something very close to 4 on the other side, look at that. That one, it just rounded to -0.5. So we can see these are very close to -0.5. And so that's our answer. And notice and I used the fraction -1/2 based on the algebra that we did. But a decimal is okay as well. Just make sure that you are answering it as -0.5 though. Okay, so our answer, so this is the same thing as -0.5, like that. That is, these are the answers. Don't answer it as this. Okay, so this is wrong. So don't use your calculator or your table and say something that it's close to. No. We want the actual point -5, the -0.5 or the -1/2. Okay, so anyway, so that's how we can check it. So, for instance, on number 3, let's go ahead and use the calculator first, and then from there we'll use our algebra techniques to double check. So, for instance, I'm going to plug this in. Now, they changed the letters around. That's okay. We treat it really in our calculator as x. So we'll just plug that in directly. So let's go ahead and clear this out. Okay, so I deleted all, so now I've got my regular, just so I don't so now it's blank. Okay, so anyway, so if they change the letter, that's okay. Just use x still in the program. So x minus 36 divided by square root, and you could type in square root, and it changes it. See that? So I did SQRT. You could also pull up the calculator button here, and there's the square root. Okay, so you can, or the keypad. Okay, so square root of x minus 6. And again, careful, make sure it looks exactly the same, and it does. Okay, and then they want us to look at 36 and again, this is just like when x is 36. So again, in my calculator, in my program, I have to look at it a little differently. Okay, so anyway, so here we go. So let me change that to projector mode to be a little bolder. Okay, so I want to find where it's 36. Okay, and I just click on it and I just kind of drag. Okay, so 36, where is it? There it is. And again, it says it's undefined because if you plug 36 into the function, so 36 square rooted is 6, minus 6 would be 0 down below, so that's why it's undefined. But I want to see what it's very close to. Again, you can kind of see, well, What number does it look like it's getting very close to as we get close to that x equals 36? Well, it looks like our other coordinate is getting close to 12. So it looks like it's 11.9 something on the left and then 12.0 something on the right. So in between is exactly 12. Okay, so that looks like it. You could also, again, use the table function. Okay, and just type in 36 to see it's undefined, and then something that's very close to 36, like 36.0001. And notice it's about 12. And then maybe slightly right of it, 35.99999. Yep, looks very close to 12. Okay, so that's what it looks like just using the calculator. It looks like our answer is 12. Okay, but to verify, let's go ahead and do this one with by hand as well. Okay, so very first step still, and we saw it in the calculator, is to plug 36 in. So my scratch work is 36 minus 36. Square root of 36 is 6. 36 minus 36 is 0 over 0. Okay, so here's my scratch work, and again, I can see, oh, that 0 right there is an issue. All right, so this time around, we see a square root involved. So that means we want to multiply by the conjugate. The conjugate of something, let's write it like this. So the conjugate of a plus b is a minus b. And then vice versa, the conjugate of a minus b is a plus b. So it's just a change of sign. So what we need to do to multiply by the conjugate is, well, I'm going to multiply this bottom by the square root of y plus 6. So I'm looking at the part that has the square root of it. And then whatever I do to the bottom, do to the top. Like that. Okay, so that was a minus. So the conjugate was just use a plus. So notice I rewrote it, but with a plus. And I am going to multiply. So the bottom portion, I would want to FOIL out. So this I'm going to FOIL. The top, we usually just leave alone. So I want to FOIL the parts that have 2 square roots involved. This top, we're just going to leave as is. Leave alone. Okay, so when we rewrite it, so let me kind of put it right here. So I've got the limit as y goes to 36. Again, the letter doesn't matter. Typically it's x, but they used y here. That's okay. And then what we have, let's get a big fraction. So the top, again, I'm just going to leave alone. Y minus 36. And then square root of y plus 6, both in parentheses. The bottom I'm going to FOIL. So when I FOIL, square root of y times the square root of y is just y. Okay, so the square root of y times itself is the y. Okay, and we can see that with numbers. Square root of 9 times the square root of 9 will be just 9 because the square root of 9 and the square root of 9 kind of cancel each other out. You're left with the bottom. Or if we could do it just like we could with numbers, we would see, hey, that would be 3 times 3. And then, well, that is 9. Okay, so we can see with numbers, it works like that. So with letters, it works the same way. So anyway, square root times the square root is the leftover underneath. Okay, and then continuing to FOIL, square root of y times positive 6 is positive 6 square root y. Negative 6 times square root of y is minus 6 square root of y. And then negative 6 times positive 6 is negative 36. And so then in the middle terms, I have the same thing but opposite. So that means these two will zero each other out. So the same thing but opposite when added would be 0. And so it simplifies into the limit as y goes to 36 of, again, leave that alone up top, y minus 36 times square root of y plus 6 over y minus 36. And then now we can see I have the same thing in a numerator that I do in a denominator. So they cancel each other out. And so we have the limit as y goes to 36 of, well, those cancel out. I'd have 1 as a placeholder down below, which I don't really need to write anymore. And then now we can plug in the 36 into that y value, and we get the square root of 36 plus 6. Well, that is 6 plus 6, which is 12. Okay, so in these, I guess, maybe it's a little messy. So here, these were scratch worky things. Okay, so this was the pure part of the problem. Okay, so that's how that one is written there. Okay, so notice again, we checked it with the calculator. It gave us the same thing. That's what we thought it was. So you can check these on them. Just notice on the calculator, just change these letters, whatever they are, into X. That's what it prefers. Okay, so like if you were to use a calculator on number 4, change those to X's. Okay, anyway, so on our, let's take a, well, let's do this one since it's another square root, and then afterwards we could take a break. So we'll put a pause on this video. Okay, so anyway, so with this problem, let's go ahead and break it down where we'll do it by hand. And to do this, well, again, first thing I want to do, I just put the implied parentheses in. But if I plug 3 in, I would have 3 plus 1 is 4, square root of 4 minus 2 over 3 minus 3. Square root of 4 minus 2 would be 0, so 2 minus 2 is 0. 3 minus 3 is 0. Okay, so again, my scratch work tells me, all right, I need to work on this. It's not just a quick answer. All right, so what we've got then, oops, not equals. What I want to do is, because I see the square root, is again, I want to multiply by the conjugate. And so when multiplying by the conjugate, the square root is like one giant term. So just leave that as is. So square root of z plus 1. Notice I don't change the sign in the square root portion. I'm just going to change that minus into a plus and then 2 to the side. And then whatever I do to the top, I have to do to the bottom. Just like that. Okay, and then like the last problem, we really only want to FOIL out what's happening when you have the multiple parts of the square root. So just the top portion. This time around, the bottom portion we leave alone. Okay, so let's go ahead and write our limit as z goes to 3. And with z, I put a little line through it so I don't confuse it with 2. So however way you want to deal with it, but I think that helps. Okay, and let's get our fraction bar. Now the blue, or the bottom, I mean, with the blue in it, 3 minus z is left alone, times the square root of z plus 1 plus 2 left alone. Okay, so they're just going to be written like that. And then in my numerator, I'm going to FOIL. All right, so when we FOIL, a similar thing happens in the last one where the square root of z plus 1 and the square root of z plus 1 multiply and they give us just z plus 1. So just the z plus 1 is left over. Now, I'm going to save a step in this. So when you multiply by a conjugate, like in the previous problem, these middle terms will always zero out. So that means when we FOIL by a conjugate, so when we FOIL conjugates, let's go ahead and put that with it, we really only have to multiply this with this and the negative 2 with the positive 2. Because the middle terms are just going to zero out. So we can skip. So FOIL with conjugates really skips those two. So it's really just multiply the first and the last. Because the outside and inside, again, will always zero each other out. So so I just want to save a step. So negative 2 plus 2 is negative 4. And then, well, let's continue simplifying it. So that is as good as it gets. So I'm just, again, saving a step on it. Where I've got this limit is, so the limit as z goes to 3 of z plus 1 minus 4 would be z minus 3. And then I have 3 minus z down below. And then the square root of z plus 1. And then plus 2 outside the square root like that. Now we're right back to where we saw, we've seen the scenario where these two are very close. The z minus 3 and the 3 minus z. Well, our strategy for that, let me just scroll back up again. We had to factor out the negative. That was in blue. Well, what's really going to happen, again, let's save another step in these problems. All I'm going to do, instead of showing us factoring it all the way out, let me put it here in case I'm going to run low on room. So our limit as z goes to 3 of our fraction. Let's go ahead and leave the bottom as is. Like that. Okay, so to factor out the negative, all I'm going to do is just instantly, so I see the orders not matching, and this is going to make the order match. I'm just going to write a negative in the front, and then switch the order. 3 minus z. Okay, and then now I have a match, and notice you can do a very quick check. Distribute the negative back in. I would have -3, which is what I have here, and then negative and a negative z would be positive z, which is what I have there. Okay, so again, it is a match. And then now I can take our binomials that are common and cancel them out. So we have this becomes the limit as z. Let me fix that z. So the limit as z goes to 3 of, all right, so the 3 minus z got canceled. I'd still have a -1 as a placeholder, so you never just change it into 0. So it's always 1 is a placeholder, and then the negative's there still, so -1. And then this 3 minus z that's highlighted is gone, and then we still have the square root of z plus 1 and then plus 2. Well, now that something's been canceled, so you might see the pattern on these now. Once something gets canceled, it usually means we could plug this value in and get a value. So we have -1 up top. 3 goes into there, which gives us 3 plus 1 is 4, so square root of 4 plus 2. And then, well, square root of 4 is 2 plus 2 will eventually be just 4. So it looks like it's -1/4. Okay, so that's how we can break these down. Okay, so I'm gonna force a break here. So instead of just suggesting to pause, I've got 4 other problems. So we'll kind of split these 8 in half, where we have 2 other scenarios that we want to deal with. Okay, but let's take a break. So stretch out. I'm gonna quit this video, and we'll start this one up whenever you're ready. So if you do have questions though now, let me know. Otherwise, thanks for watching.